Problem number 12. I need to find out the value of load resistance to get maximum power at load from rest of the circuit, and also I need to calculate value of maximum power at load. I am following maximum power transfer theorem. First I need to find the open circuit voltage. So removed this load here. Potential across this and these points is the open circuit voltage. To get the value of open circuit voltage, I am using nodal analysis. Say at this node potential is V. This point and this point are same. So using KCL at this node, this is inlet current 5 ampere. This current has been divided into 3 paths. One is this one. Say this is I1. Another one is this one. Say this is I2. Another one is this one. Say this is I3. So this 5 ampere is the summation of I1, I2 and I3. So first, what is I1? I1 is the current flowing through this 1 ohm resistance. So potential at this point is V. So V minus this 15 volt divided by 1 ohm, this is I1. So see, this is I1. Next, what is I2? I2 is B, this is ground, so B by 10 ohm, this is I2. So this is I2. What is I3? I3 is flowing through this path. So I3 is this B divided by 2 plus 3, this is I3. So this I1 plus I2 plus I3 is equal to 5 ohm. Simplifying this, I got value of V is equal to 15.4 volt. This is potential at this point. Now what is VOC? VOC is potential at this point with respect to this point. Now this is open circuit, so no current is flowing through this path. So potential at this point is same as potential at this point. So VOC is potential at this point with respect to this point. So VOC is equals to current flowing through this 3 ohm resistance multiplied by this 3 ohm. So what is current through this 3 ohm? So current through this 3 ohm is value of this V divided by 2 plus 3. So value of V is 15.4 divided by 2 plus 3. This is the current flowing through this 3 ohm. That multiplied by this 3 is the potential across this 3 ohm. So ultimately VOC I got 9.24 voltage. Now to calculate RTH, open this load resistance. Here the sources are replaced by their internal resistance. The current source will be completely open. Say current source completely opened. Voltage source will be shorted. Voltage source is shorted. So this is the combination, and from this resistive combination I need to calculate RTH. If it is difficult to understand which resistance is in series or which resistance is parallel, then we can redraw this combination of resistances in a simpler way. Say I have started from this point A. Say this is B. So from A I am starting walking A, first 5 ohm resistance. From this 5 ohm resistance I got 2 paths. This is one path, this is another path. So one path is having 2 ohm, another path is having 3 ohm. This 2 ohm at this point, again we got 2 paths. One is 1 ohm, another one is 10 ohm. So from this 2 ohm, 2 paths, one is 1 ohm, another one is 10 ohm. This 1 and 10 met at a particular point. Say this is that point. This point and end of 3 ohm are same. So this 3 and these are same point, and ultimately the point is B. Now it is very clear that which one is in series, which one is in parallel. So first 1 and 10 are in parallel. Say this will be in series with 2 ohm, this one, and combination of this is in parallel with 3. So this is parallel with 3, and combination of whole is in series with 5. So this is plus 5. So ultimately say here 10 parallel 1, equivalent of this is in series with 2, equivalent of full is in parallel with 3, equivalent of this full is in series with 5. So ultimate after calculation I got 6.47 ohm. This is RTH. Putting it into equivalent circuit, VTH is 9.24 volt, RTH is 6.47 ohm, and to get maximum power at load, the value of load resistance will be equal to this 6.47 ohm. See here, 6.47 ohm. Putting the value of open circuit voltage 9.24 and the resistance is load resistance, that is 6.47 ohm. Ultimately we got maximum power is 3.29 watt. Now checking whether my calculation is okay or not. See here, in equivalent circuit I have used 9.24 volt, 6.47 ohm is Thevenin resistance. The load resistance is same as 6.47. In main circuit also I have used load resistance 6.47 ohm. Now if power at load in main circuit and power at load in equivalent circuit are same with the value 3.29 watt, then it will be confirmed that my calculation is perfect. Now running the simulation. See here, in main circuit is showing power at load is 3.29 watt. In equivalent circuit power is showing 3.30 watt, which is very near to 3.29 watt. So my calculation is perfect.